So following on from the previous video, we got to this stage here, but then we can't simply apply the formula, because in order for us to apply the formula, we require n to be 1. Here our n starts in the middle of nowhere, so we can't simply apply the formula. So in order for us to do this, we need to get this to be on par with the 2. So we need to get this n here to be n minus 2, so that this could be on par with this. If you're trying to sum from n equals, let's say 28, then in order for us to do this, we need to get this to n minus 28, so that this thing here could be on par with this. Now at the moment you don't understand why the two needs to be on par with each other. Hopefully later on you will. So the trick here is to the trick in doing this is to get this. So our first step is to get this to be n minus 2, so that this could be on par with this n equals 2. So rewrite this as this. So this is a constant, this is a constant. So rewrite it as this, because if I were to give you a fraction to the power of 1 times the exact same fraction to the power of n minus 2, then you would get this plus this, which would then give you that same fraction, n minus 1, which is this thing here. The point here is that you can rewrite this as this. So here, this is a constant, this is a constant. The good thing is that this is now on par with this. And remember, you don't understand why we require it to be on par, but hopefully later on, hopefully you will. So now this is a constant, this is a constant. Merge them together, that will then give you this. So what we're trying to find out is this thing here. Now, when n equals 2, if you put it into here, 2 take away 2 will be 0, so this will be 1, and then this, so this is our first term here. This is our first term when n equals 2. When n equals 3, put it into here, this will be 3 take away 2 will be 1, so that will make this to be 1 times this, that will be e to the power of 3, and then this times this will give you this. So when n equals 3, this whole thing here will give us this. When n equals 4, this whole thing here will then give us this. So this is what we're trying to see. We are trying to find this out. This will then give us this. So we are trying to sum up everything from the first term all the way to infinity. But the good thing about this being on par with this is that this is exactly the same as this. You notice that this is on par with this, and even if you have n to the power of 37, because this is on par with this is exactly the same as this, and this is exactly the same as this. They're all the same as long as they're on par with each other. So if you look at this, what I'm claiming is that this is exactly the same as this. So let's test it out. When n equals 1, put this into here. 1 take away 1, that would be 0. So this whole thing here will be 1 times this thing here. So the first term will be this. Now when n equals 2, put it into here. 2 take away 1, that will be 1. So that would mean this times this. E squared times e. That's e to the power of 3. 27 times 3. That's this thing here. The point is that this is exactly the same as this. And even if it's n equals 37, because this is on par with this is exactly the same as this. So this is what we're trying to find. But rather than looking at this, because we know that this is exactly the same as this, we can use this to because this is something that we're familiar with. N starts at 1. We can use this formula here, because just bear in mind that bear with me. Just bear in mind that this is the same as this, and then this is the same as this. But we know that when n equals 1, we can use the formula here. So all you need to do is extract your a and then extract your common ratio. So this is your a here. So put it into here, and this is your common ratio. put it into here. But then, because we know that this is exactly the same as this, we can just extract the constants here, and then we can just extract the common ratio, because we know that this always works when n equals 1. But then the point here, the point I'm trying to make is that this is exactly the same as this. So even if you have something weird like this, you can just extract your constants, and then you can extract your common ratio, because you know that they're all the same. You know that they're all the same. When n equals 37, put the 37 into here. 37 take away 37, that would be 0. 0, then making this whole thing here to be 1. 1 times this. When n equals 37, your first term is this. When n equals 38, put it into here, and then your next term will be this. When n equals 39, put it into here. This whole thing here will be this. The point here is that this is exactly the same as this. This is exactly the same as this. So you wanted to evaluate this, you can just imagine it to be like this. Extract your A, extract your common ratio, then that will then give you this. Okay? So you can simplify this yourself.